It's like going from 10 to 7 minutes than the original. I can do it in terms of the rocket's flight. I can do it. I think so. The rocket flies. You're like 14 and then 14.
Oh, wait, but these are in
Can we use the calculator?
I believe this is a non-calculator one. Ari, what can you explain? What is crazy about this?
No, my bad, no. I looked at the ones like Delta Math that did have the nice increments. These do have nice increments.
Okay, so the Delta Math tries to make it behave, but sometimes it chooses ridiculous things.
Just random numbers on Delta Math.
Well, these are kind of random numbers as well. So rocket has positive velocity after being launched upward from initial height of 0 at time 0, and then they give you snapshots of the height, velocity from 0 to 80 seconds. So I actually don't want to do the meaning part first, but doing midpoint, can you guys do that?
I can. What you have to do is find the sub-intervals by dividing the distance by the amount of intervals and then by 2.
So, one catch to this, the interval they asked for is smaller than the data they need. So from 10 to 70, they want you to do midpoint. How big is our dx?
20?
20? Because 10 to 30, 30 to 50, 50 to 70?
Yeah.
Okay, so
70 minus 10 divided by 3 is 20.
yesterday we did find the area of this rectangle, find the area of that rectangle, blah, 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 and then add them all together. This one, dx is uniform. It's the same each time. I'm going to factor it out. And then it said to use left ends, midpoints, or right ends. Midpoints. So the midpoints are the ones in the middle. So if I did 20 times 22, that's rectangle 1. And if I did 20 times 35, that's rectangle 2. And 20 times 44 is rectangle 3. So what does that come out to be? 2020, 2000. Okay, so to show you what they're looking for, 2020 feet. So in this question, so on the AP exam, they will ask you one of these. They want to see that you used these units. So in the work that they're showing here, you need to show one of those lines. It's tedious. They need to see you chose the right midpoint, or you chose the left end. I need to see that you used the left end value or the right end value. So you needed to have one of those lines, either saying V of 20 or the actual value. And then the numerical answer with units, you get a point for that. Something we didn't talk about yesterday was using correct units to explain the meaning of this. So this is adding up all the accumulated change. Velocity here is feet per second. dt is seconds. So the units that I'm getting out of this are feet, right? So interpreted in context of this problem, this one has something special to it that they're overlooking, but they're like, oh, velocity's always positive, so it's forever going up, so it's the amount of distance that it's traveled in 10 to 70 seconds. So there's one small thing we're doing today, which instead of rectangles, we're gonna do areas of trapezoids, okay. But there's something else on the delta map that is this thing of interpret the units, and they are generally a royal pain. And when they ask you interpret in the meaning, in the context of the question, what's going on, they want some kind of noun. What is this? The rocket traveled some distance. What's the unit? It traveled in feet. And what is the time frame that you're talking about? Is it your instant rate of change at 2 seconds, or is it the total distance traveled from 10 to 70 seconds, as in this one? So they always say, they want the nut of the problem. Give me a noun, the unit, and then the time frame that you're talking about. And you will see when you get to the annoying delta math questions. Yeah.
So, sorry. If it's like decreasing, like if the velocity is decreasing, but it like starts from like a really positive number and still is positive, is that also the distance traveled?
So that comes up later in chapter 5. Distance traveled. Are you wearing Fitbit or not? So is it displacement, which is integration, or is it just total distance? That's a little, we'll get there. We're not there yet. Okay, so I just wanted to show you how AP asks this and what it's going to look like. And it's here, so I will ask this also. Average acceleration over 0 to 80 seconds. So average rate of change versus instant rate of change. Instant is you do the derivative. How do I find average velocity, Kelly?
You find like the slope from 0 to 80 seconds because it's like already velocity.
The slope using the velocity points?
Yeah.
Do you guys agree, physics people? Well, okay, let's think about what she said as units. Velocity at 80 minus velocity at 0 over 80 minus 0. This is, as units, feet per second divided by seconds. Is that the units of acceleration?
No.
Feet per second squared, isn't that gravity? So, yeah. And this is just one point on the AP grading to do the numbers and get the units with it. All right, so I'm going out of order. This is 5.5 instead of the others. It's just doing areas of trapezoid. It's no big deal. What's the area of a circle?
Pi r squared.
What is the circumference of a circle?
2 pi r or pi d.
2 pi r or pi d. Happens to be the derivative of circle, of the area. Area of trapezoid?
Area of trapezoid is the height of the base times the sum of the two bases times the height divided by 2.
So if you think about an area of a trapezoid, if you cut the little triangle off and paste it on the other side, it makes a rectangle. It does work for all trapezoids, not just isosceles ones. But yeah, okay. area of trapezoid, half. Average the bases, multiply by the height. Okay, because we're gonna use that a lot. Looking for an example to put on today as a warm-up with rectangle approximation method. I found like 10 trapezoid examples to one rectangle. So I seem a little more obsessed with trapezoids. So with this equation, find the area of those two trapezoids, which area of trapezoid again was what? Average of the bases times the height. Okay, so find those two trapezoids and add them together. The bases and the heights are in places that you don't like. Gus is turning his head sideways like, what the? Sitting on its butt. Questions? Anybody have an answer? So you guys really don't like when the trapezoids aren't oriented the direction you like. These are all tipped up. Trapezoid 1, base 1 plus base 2 times the height. The height is this distance. But I needed to average the bases, so it's times a half again, right? 5/4, 9/4, 9/16.
Yeah, got that.
And the second trapezoid, this one plus that one, 5/4 plus 2 times the base times the half. All total? Yeah, we agree? And as I said, the IP exams, they seem to be obsessed with this. They often put it on a non-calculator section. So it's usually, they ask for 3 little trapezoids added together. And the numbers won't be too terrible, but they might be like this. Yeah, so there's a small delta math today that's just show me that you practice trapezoid rule and then some interpret the meaning of trapezoids, or what the meaning of the integral is. Okay. we need to discuss some of this. Physics people, area under the curve when it's below the curve. You guys aren't there yet? Okay. So integration gives you your distance traveled. So if the area under the curve is below the curve, you're moving to the left, or you're moving down, you're moving backwards. So it's not really negative area, it's indicating direction. And this stuff is moving forward. And Cecilia, you asked like something about, is it always, I can't remember. But in this question, if I said do the integration from the beginning here to the end here, it isn't like if this was that area down there as a positive number was 5 and this area up here was 9, this stuff here, this negative stuff, that would be -5 plus 9. So the answer to the integral is displacement. You ended up 4 feet ahead of wherever you started. Versus if you wanted total area, like what did your Fitbit say? You ran around the track 8 times and you went nowhere. If you wanted to know what your Fitbit would say, it would say absolute value of that. Okay. Good question. And this trapezoid rule, they don't care that, oh, yeah.
I'm a little confused. You're saying the area under the curve, but like, isn't the negative area under the like, even like under the axis?
Okay, so
Okay.
trapped between the x-axis and the curve. So this, you're right, it's not exactly under because the curve is the bottom part, but trapped between the x-axis and the curve, what is that area? When it's down here, it's negative, or meaning I'm going backwards or I'm going down or the opposite direction. And trapezoid rule, they didn't care that the trapezoid crossed over. Average the bases and multiply by the height. And so it's a little bit negative and a little bit positive, kind of almost cancels out. And mathematically it'll all work out and you'll be fine. Okay, so our favorite one, just like yesterday, can you show me you can do the trapezoid rule? With x squared, use a calculator. 6 slices equally distributed from 0 to 3. Nick, what is your hint that you're saying?
You can use the middle wall. Because they're used twice in 2 trapezoids, you can multiply them. Like you could write it all as one equation and multiply it by 2. And like sum them together and then.
I'm going to tell them that till after this. Okay, so he's saying, all right, it's sort of a shortcut. Area of a trapezoid, area base 1 plus base 2 times height. In this one, which please keep in mind they're not always uniform, but in this one, is the height the same in each place? Okay, so I'm going to factor the height out for all of them. And that half for averaging the bases. And what Nick just said, okay, base 1, that's f of 0. But base 2, this guy, is the bottom of that trapezoid but the top of the second one. So he said, just double it. And, oops. And I want 2 of those because it's the bottom of one trapezoid but the top of the other. And then only one of those guys. It doesn't save a lot of time, but save some. No? Yes. Yeah, bust out the calculators. What do you get? Answers yet?
138 over 16.
And then as a decimal, what is that?
God, calculator.
What'd you get?
8.6 is this time usually.
8.625? Haley's agreeing. I have a different number written down.
18.125.
18.125? 9.125? Well, at least there's options. What'd you get?
5.125.
5.125? Okay, so in getting these, it's easy to drop a 2, forget a parentheses. I got 9.125. And yeah, on a test, you're not going to be asked to do 6 slices unless they're super easy. Generally, it's 3 or 4. And as I just said, when looking for problems to give you guys today, the number of trapezoid rules that came up, hands down, was the bigger representation. So don't stress too much about it if you got the wrong thing. It's just a matter of carefulness. But I want to ask about over and under approximations. Yesterday, did I mention, I didn't in one class and I don't remember which one. If we were doing LRAM on this guy, would it be an over or under approximation?
Under approximately because LRAM and increase it.
Okay, so LRAM would make an under approximation when F prime is increasing, okay? RRAM would be an over approximation because it's saying take that side. Okay, undo. What about with trapezoid rule?
That would be it would still be LRAM, but it would
Slightly.
go above
LRAM?
curve. Be a direct line.
So this LRAM,
Over
would, and is it because of increasing?
Yes.
Nick says concavity. Let's see, I gotta find my GeoGebra thing to show you again. Is it,
I would want to do the progressive like
For Elbert.
Well, 'cause
No,
here's the
the
thing, it's not
trapezoid
like there is
rule.
an
Oh, yeah, that's, I think, still like fill it
Spinning wheel of death, sorry. Looking at x squared, and let's look at both sides to see if it's related to concavity.
+3.
Thank you.
Oh, yeah, for square, but we're talking about how we then did this. I think.
So LRAM when it's decreasing is an over approximation. LRAM when it's increasing is an under. Don't memorize it, draw it out and be like, okay, which way does this go? RM, the absolute other way around. If it's increasing, it's going to be an over approximation. If it's decreasing, it's going to be under. And sorry, I thought this had trapezoid rule on it, and it doesn't. But trapezoids, if I was to connect here to here, show better with fewer. Nick said it's concavity. So if I connect these coordinates, when it's concave up, you're going to have the little straight bars a little bit over. When it's concave down, the little straight bars are going to be below. Looking at it on this guy. So concavity is how you read trapezoid rule. And just draw the U shape and see if it makes a difference depending on which side you're on. Yeah.
With an over and RM, when the function symmetrical, would it be like exactly equal? Because the amount of space given up here is the same amount of space that's been taken up extra.
Not necessarily, and don't generalize something like that. It's not a useful thing.
It's not useful.
Like, it's not worth the brain space. You'll figure it out when you are presented with a problem by just thinking rather than memorizing. Okay. So the LRAM, RRAM, it's a matter of first derivative. Trapezoid rule, it's a matter of second derivative. And just draw it out. Oh, it was concave down. Okay. If I drew some trapezoids in there, looks like it's going to be missing a little bit of that top curvy bit. Okay. Try that one. So those are temperature readings from noon to midnight. So are you using all the temperatures they gave you? No. I believe I used to ask for midpoint as well as trapezoid, and it was just unexciting.
And when do you have to go?
Like 5 minutes or
Because there's someone that is in this class that didn't come. Like, I gotta go play.
if I need an hour to change.
So doing trapezoid rule, what did you guys get?
I'll say
780? So something's wrong. It says estimate the average temperature for the 12-hour period. Is it 780 degrees? No, you didn't. Okay, so
Oh, wait, it is wrong.
So what you guys did doing the trapezoid rule, because I didn't tell you to do anything else, was add up all the temperatures. So you accumulated that much temperature, but somebody just said, do you divide it by 12 because average, it comes out to be 65. Okay, and I still don't have a great answer for this, but I taught Algebra 1. If I asked Algebra 1 to average this, they would add up all the numbers and divide by the number of numbers and go, here's your answer. And that would be their average. And I would be like, yeah, you're right. And their answer would be like 64.5. It's really close, but a little bit different. Any reason to use one over the other? Any comments on that? Nick, you were about to say something, you're like, never mind. Okay, okay, sister works in the census department, outliers, statistics, there's things. Doing this style, it takes into account the middle stuff more and less on the outliers. It might be colder or something at the beginning and end when you're doing temperature like this. And I don't know, I still take issue with this particular example of average, algebra 1. I'd added all the numbers, divided by the number of them, and gotten an answer. For AP purposes, they will often give you a function, and they'll say, we want the average from A to B, and they don't say anything specific. They're not like, here's your 10 data points. They say, here's your function. Now that, do you take 50 sample points and add them and divide? Like, so there is a reason for doing, saying calculus-wise, this is adding up all of the numbers that could have been numbers, and then divide by the space, the number of numbers, the gap of time, whatever. There's that. Yeah. All right. Do we want to do one more example of a car traveling on a track, or, ooh, yuck, not that. And I very briefly mentioned what the absolute value thing, what is that gonna do? Distance. So it's like any distance you went backwards, we're still gonna count it on the Fitbit.
Just like averages 30 and 51.
Brooke, do you know what's going on or? No? Okay, so the integral of velocity. Physics people will tell you the integral of velocity is going to be your displacement. This is the integral of absolute value of velocity, so that means if you were moving backwards, we're going to count it as still distance traveled. So the meaning of this is the total distance traveled by, so noun, total distance traveled over in what units? Feet. Total number of feet traveled over what time unit? 30 to 60 minutes. And they want all of those details. And they've changed their grading schemes. This is what they look like now. They didn't as a pre-COVID. So this part A, they want to see 1 point for the explanation. The explanation is this is the distance in feet the car travels from 30 to 60 seconds. Last year, grading these, if students didn't say, if they said it's the number of gallons that went in over 30 to 60 seconds, they didn't get the point. They needed to say gallons of water or gallons of gas. So I argued a lot of those. I kicked them all up back to the table later. Just like, would you believe me already? They said no. They have to say gas. So do you need to say the car traveled? Put it in there because for fun. But you definitely need to say over this time window, 30 to 60 seconds, you definitely need to say it was total distance traveled from in feet. And then the answer, they want to see that you use the right numbers. They want to see that spelled out. And for the AP, you can leave it here. For me, you need to finish. But when the AP exam comes around, I curse you all when I get to these papers and they just leave it and they walk away. It's accepted. And I feel bad for kids that do this right and then write dyslexia things like 158. Like they had the right answer and then they took it away. So anyway, there's that. Yeah, I don't have anything else. And for those of you who haven't done the Delta Math, sorry.